Why are you here? You're here because you don't answer these questions. This is a very common CRI, very common multiple choice mutations questions are, okay? Get some paper, pause the video, and try this. Get it wrong now so you don't get it wrong on your test. Okay. The answers are all short, so let's get through this. Researchers observed DNA sequences of two cells that were thought to be identical. So the DNA is thought to be identical. The researchers found a silent mutation. So there's our first keyword. I'm going to underline that. Silent mutation. The researchers did not know any phenotypic change. That's what a silent mutation is. It's a change in the DNA that does not change the phenotype. All right, it's still a mutation, but it doesn't change the protein. Now, how is this possible? All right, that's what part A is asking. Explain how this silent mutation can happen, yet there's no change in the phenotype. All right, and the key is the genetic code, which is here. This is the one we've used in our class, is redundant. Okay, so look, how many codons can result in the leucine amino acid? Oh, there's 1, 2, 3, 4, 5, 6. All right, how many codons will lead to the valine amino acid? 1, 2, 3, 4. Every amino acid has more than one codon, more than one way. So even if, okay, so if this U, or on the DNA it wouldn't be a U, but if that base mutated into another base, you're still likely to get the same amino acid. All right, so you got to know this word. So it's a key word for silent mutations only, okay? The genetic code is what? Is redundant. Now you don't have to say that word, redundant, but you got to explain it. It's just easier to say redundant sometimes. Okay, what it means again is there's more than one way, more than one codon that results in an amino acid. That's what redundant means. More than one way. All right, part B. Describe how a genetic mutation could lead to a phenotype change. All right, well, you could pick any other mutation because every other mutation is going to change the phenotype. All right, but don't forget to just describe it. All right, let's just go with one of them. Missense mutations can change an amino acid. All right, and therefore will change the phenotype. All right, another thing you could say is a nonsense mutation can shorten a protein. That's also going to change the phenotype. In other words, the trait. Okay, you can say a frame shift changes multiple amino acids. These are all very good answers. Just pick one of them. All right, part C. How can a mutation change the allele frequency or the gene pool? The gene pool, the number of alleles in a gene. Mutations can add alleles. Remember that. Evolution cannot. Only mutations can add alleles. Mutations can create new alleles. All right, evolution can, if it doesn't favor it, it can remove it. All right, how can it affect the pot? It can add mutations. I'm running out of space. All right, mutations can create new alleles. Those alleles are versions of genes. Okay, which increases the gene pool. You can say increasing the gene pool. That means there's more variation. Increasing gene pool. All right. Study this video